Hello everyone, this is my brain tumor classification demo. So we have loaded a glenoma tumor brain scan MRI into our demo. Now we're gonna run side-by-side comparisons of the three models we have trained: exception, ResNet at 50, which are both transfer learning models, and our custom CNN model. In the saliency map section, we actually can see the original image and the actual vision of each model of what it actually focused on to make its prediction. So you can see exception ResNet do seem to be looking at the appropriate area, but the custom CNN doesn't appear to be looking at the brain at all, or at the boundaries. So it might have trained itself on the training data to make its predictions like that. Regardless, we have our classification results here. All of them classified with 99.9% confidence. We can see the probability distributions of all the other classes. So, for example, the ResNet model actually had a bit more confidence it would be a pituitary tumor rather than no tumor at all. Next, we can generate reports on what the neural network has actually observed and why it made that prediction. And we can have one of three models to actually make that prediction. We have Grok for the Llama LLM, OpenAI for its own LLM, and Gemini for its own LLM. Let's use OpenAI, for example. So again, might take a bit because we're actually passing all this context, the image as context to the LLM, and it's generating its response. So for the OpenAI, I'm actually using the OpenAI 4.0 Mini to not waste so much API credits. Regardless, here we have our mode prediction, our additional insight, relevant historical cases, and next steps for patient and doctors. Again, this is meant to be just for the patient, and as such, we want to be very empathetic. So we have actually made a chat with LLM to actually talk with someone in that case. We have made our LLM very empathetic in this case because this is hard news for the user. So we actually type it and we wait for a response. So as you can see, it is very empathetic. It's not like a doctor or even a machine. So we can ask this both questions. Just gonna wait for its response, and it answers pretty quickly. Let's see, I'm scared. And yeah, as you can see, it's very empathetic with us. Also, for the LLM, we're actually passing all the history or conversational history to actually like output an appropriate response with memory per se. Also, we can clear the chat if we want to actually clear all. Now, another feature I added was that it actually has like a cache, sort of cache, a session state. So if we remove the custom CNN, it doesn't load the whole exception ResNet models, which is very important because this takes like 5 seconds to actually run. As well with the LLM responses, we actually store them in our cache. Also, if we load it back in, this is immediately as it's stored in the cache again. To end, let's actually see another model, another training image, for example, a Gnome again. So this will actually make it everything load. As I said, it might take a bit because we're actually running three neural network models, which take around 1 to 2 seconds each. So in the future, we could actually try to make it much smaller as the custom CNN model. But again, it isn't as accurate as the exception or the ResNet. So we have these predictions, and again, probability distribution. As you can see, the custom CNN probably predicted a much higher meningoma chance than the other uh, models, but regardless of that. And again, we have a report. In the future, I would actually like to implement. Wait, this is still loading, sorry. Okay, so as I said, in the future, I would like to actually make this speech to text and text to speech for the LLM. So the user can actually like talk to it, because again, it's more on the use case side of things. So if you are like shocked with this news, you might actually want to like talk to someone rather than like type it. And as well, you might actually want to listen in an empathetic response rather than like reading while you might be crying, for example. Oh no, this is my demo.